Welcome to P.U.R.E 6. Today we're going to see chapter number 3, Magnetism and Magnetic Effect of Electric Current in class 12, 6th Tamil board. Today's topic is magnetic dipole moment and magnetic field. So let us move to the first topic, which is magnetic dipole moment. I'm going to consider a bar magnet which has south and north pole, and the QM represents the pole strength. And what is pole strength? Pole strength is the measure of the strength of the magnetic pole. That is, it just tells us how the magnetic pole has the strength to attract the poles of the other magnet. So QM is represented as QM is called as the magnetic pole strength. And the point O is the geometrical center of the bar magnet, and the length between, or the distance between south pole and the geometrical center is called as L, and the distance between O and N is L, and the total distance between south and north pole is 2L. Now, what is the definition given in the textbook is that magnetic dipole moment is defined as the product of the pole strength and the magnetic length. What is the pole strength here? The pole strength is Qm. What is magnetic length? Magnetic length is nothing but the length between the south pole and the north pole. This is called as a magnetic dipole moment. When you product those pole strength and the magnetic length, you will get the magnetic dipole moment. But it is a vector quantity, so we should represent the magnetic dipole moment in terms of vector. So I'll just draw a vector on this bar magnet. This green line or this green vector is called as D vector. What is this D vector? D vector is a vector drawn from south pole to north pole, and the magnitude of D vector is equal to 2L, because it is same as the length of the bar magnet. So I can represent the equation. Now I need to express this magnetic dipole moment in terms of expression. So using my definition, that is, what is my definition? It is defined as the product of its pole strength. So there is some product here. There is some product. What is between those product? One is pole strength. What is pole strength? The pole strength is Qm, and the other side of the product is magnetic length. Magnetic length, since I need to represent this magnetic dipole moment in terms of vector, I'm going to put a vector symbol. I cannot put a vector symbol for the pole strength because it doesn't give me my direction. But my magnetic length can have direction, because D vector shows that the vector is always going from south pole to north pole. So in that phase I can put D vector. So when I take the magnitude on both the sides, that is, when I need to find the magnitude of the magnetic dipole moment, I need to put a magnitude symbol and wherever the vector symbol is. So magnitude of PM vector is PM, because the vector and magnitude will get cancelled, and in the place of QM we'll write QM, and magnitude of D vector is 2L. So it will be 2QML. So this is called as the magnitude of magnetic dipole moment, and its unit is, and the SI unit for this magnetic dipole moment is ampere meter square, because the unit for pole strength is ampere meter, and the unit for the magnetic length is meter. So when I multiply ampere meter and meter, I'll be getting ampere meter square. So again, I'm saying that the magnetic dipole moment is defined as the product of its pole strength and magnetic length. Here magnetic length has been represented in the form of vector because my general form is magnetic dipole moment vector, and the vector is always from south to north, and the magnitude of the vector will be equal to the magnetic length of the bar magnet. So therefore, when I take magnitude of D vector, I will get 2L, and in the place of QM I substitute QL, and when I take the magnitude of this dipole magnetic dipole moment, I get PM. So PM is equal to 2 times QML. So this is my equation for magnitude of magnetic dipole moment.